Greetings. Hello. Welcome to PCAP's Native Prairie Speaker Series. My name is Caitlin Rose-Seiler, and I'm the Stewardship Coordinator with Saskatchewan Prairie Conservation Action Plan, or SKPCAP. Today, Anabel Dombro, a Range and Conservation Stewardship Policy Analyst with the Government of Alberta, will be speaking about the management of annual brome invasion within northern mixed grassland using indaziflam. Before we begin, I'd like to state that we respectfully acknowledge that we are on the traditional territories of many Indigenous nations and communities, past and present. For millennia, they have worked to protect these landscapes and the life these areas sustain. I'd like to thank these original caretakers and acknowledge the ongoing work and presence of Indigenous peoples in Canada today. And just a few items before we get going, I'd like to note that PCAP's Native Prairie Speaker Series is a monthly presentation about anything to do with Native Prairie conservation or species at risk. And details about our June webinar will be released shortly. But I'd like to invite you to join us on July 30th. Mike Blom will be speaking about migratory birds at the Red Berry Lake Biosphere Reserve. And you can sign up for that on the PCAP website. A reminder to our listeners out there, you'll be muted for the duration of the webinar, but if you have any questions during the presentation, please feel free to type it into the Q&A section of the webinar dashboard at any time during the presentation, and feel free to upvote other people's questions if you have the same one, and then questions will be answered towards the end of the webinar. I'd like to take a moment to note that financial support for today's webinar is provided by our presenting sponsors, Canadian Forage and Grasslands Association, North American Helium, Nutrien, Saskatchewan Cattlemen's Association, and SaskTel. In-kind support is provided by Birds Canada, Canadian Wildlife Federation, as well as the Government of Alberta, University of Alberta, and NBU. I'm pleased to introduce today's presenter, Anabel. Anabel Dombro defended her master's in Rangeland and Wildlife at the University of Alberta in January 2023. She's now working as a range and conservation stewardship policy analyst with the Alberta provincial government. And Anabel's from Edmonton and in her free time enjoys rock climbing and playing soccer. So with that, I will pass it over.
Thanks, Caitlin. All right. Thank you everyone for coming. I'm excited to share my research with you all today. So yeah, my master's research was about the management of annual brome invasion within northern mixed grassland using indaziflam, and I'm going to get into what exactly that means. So first, a little bit of background about annual brome grasses. So brome grasses with annual life cycles are undesirable plants, and they reduce ecosystem function. So first of all, they're a low quality forage for livestock and wildlife because they're early senescing and quite unpalatable. And so these species, they have the annual life cycle. They typically act as winter annuals where they start their growth in the fall and then overwinter and then quickly resume their growth in the spring. And that can also help them compete with native plants in the early spring for like limited soil moisture and nutrients. So this can lead to reductions in biodiversity where they're invading because they compete with more desirable native plants that we would probably like to see more. And this can result in a shift of vegetation structure to annually dominated vegetation compared to perennials. So that's been like frequently seen in the United States in the Great Basin, especially in the sagebrush ecosystems where sagebrush has been like really replaced by annual grasses, leading to like basically annual grasslands. And then they also have highly flammable litter, so this can lead to an increase in the fire return intervals. And that can also be a bit of an issue. So I also, just wanted to mention that they also have like a lot of seeds, so that can also help in how they invade. So essentially those are some of the reasons why we consider these weeds and why we like probably don't want large amounts of them on our rangeland. So some of the common species of annual brome in our Canadian prairies are the our downy brome, Bromus tectorum. So this is also known as cheatgrass. You might have heard, because this is definitely the most common species and the most well studied of them. But what we've also found is that in Southern Alberta, we have this species called corn brome, Bromus sclerosus. There's also Japanese brome, which is Bromus japonicus. And these species all act pretty similarly and invasively. Some of the other annual bromes that you might see in our prairies are rye brome, ripgut brome, meadow brome, soft brome. They all look and act quite similarly. And the spatial significance of this invasion is really large. So these species are considered to be like one of, if not the most problematic rangeland weeds in North America. So they're found in every state of the US and province in Canada. And tens to hundreds of millions of hectares have been affected in the Western United States. So that's really where the epicenter of the problem is right now, is in the Great Basin and the Great Plains. So here in Alberta, in the grasslands of Alberta and Saskatchewan, we're on the northern tip of the Great Plains, and it seems that these species are potentially spreading north where they've historically been less abundant. So here are a couple of maps of Alberta that I made using data from the Alberta Biodiversity Monitoring Institute and the Alberta Environment and Parks range health surveys. So you can see that there's like a higher density near the border of Montana, and I would assume that probably goes east into Saskatchewan as well. In terms of control options, they're pretty limited. We have pretty limited control options at the moment. In terms of grazing, it hasn't really proven to be the best method of control because annual bromes senesce very early in the season and become unpalatable early on, which reduces livestock use. So this is a picture of some clumps of brome that I saw at one of my sites one year when we had a pretty thick layer of annual brome. It seemed like the cattle had like chewed a clump out and then just spat it out. So they were avoiding this area, this patch of brome, and also the native plants that would be intermixed with that. And it's been found that herbicides can provide potentially better long-term control. But even with herbicides, there's pretty limited herbicide options to date because most herbicides registered are for cropland. And one herbicide, imazapic, that has been used in the United States for attempting to control brome. That one's not registered in Western Canada. And we've also started to see some herbicide resistance to group 1 and 2 and recently glyphosate herbicides. So those are not great options either. So it could be helpful to have another potential control tool. So this is indaziflam. Indaziflam is a sort of new to rangeland herbicide that was registered in the United States for use on rangeland and natural areas a couple of years ago. It's called Rejuvra. And it's not registered in Canada yet, but it is in the process and is supposed to be registered very soon here. So how it works is it's a cellulose biosynthesis inhibiting herbicide that affects seedling germination and emergence. So it's a soil applied herbicide. It's not meant to target the foliage of already growing plants. Like you want it to get into the soil. So after it's applied, it needs precipitation to incorporate it into the topsoil, where then it is supposed to control the seed bank by preventing seedlings from establishing. And the properties of it mean that it also can reside for a long time in the soil, potentially depleting the annual brome seed bank. which is thought to remain viable for around 3 to 5 years. So this is a non-selective herbicide in that it will, it's assumed to disrupt the establishment of all types of seeds, including grasses and forbs, so monocots and dicots, and like perennials like natives and also invasives. So the idea is that there's less impact to perennials because perennials do not rely on seed as much for their reproduction, compared to annuals that solely rely on that for their reproduction. And then that perennials, they are already growing. They have a prevalence of roots below that treated indaziflam layer in the soil, and so they could sustain their growth through that while the indaziflam acts on the annual brome. So the objective of my research was to generate regionally tested and relevant information about the use of indaziflam for managing annual brome grass within northern temperate rangeland, where our northern rangelands have a cooler climate than studies done in the United States, as well as soils higher in organic matter. So typically, as we move northwards in latitude, our soils increase in organic matter, and that affects herbicide properties and how herbicide works, how long it will last in the soil, how it's like absorbing to soil particles. And we also have cool season grasses that dominate our vegetation. We might have a different suite of annual brome species, such as corn brome is quite dominant here. And we also have rangeland in healthy condition that otherwise should be resistant to invasion. So that's in contrast with a lot of studies that have been done there actually aren't that many studies that have been done, but the studies that have been done in the United States have been done on more degraded rangeland that was really highly invaded already. So in part one, I determined the expected magnitude of brome reduction for 4 years following a single indaziflam treatment at different rates and seasons of application in the field. So for this field study, we had 2 study sites in the dry mixed grass natural subregion in Southern Alberta. So it's pretty dry there. We have Chernozemic soils high in organic matter, and we have a pretty healthy grassland that was stocked relatively lightly. And then at each of those 2 study sites, we had a small plot experiment where we had a randomized complete block design with 4 reps. And then we applied herbicide one time in either the fall of October 2019 or the spring of April 2020 at 4 different rates of indaziflam, which were 0.51 and 2 times the US recommended rate, which is 75 grams of active ingredient per hectare. And so, yeah, we applied the indaziflam only once, but then monitored for 4 years. So we sampled the biomass density and cover of all plants at their peak growth from 2020 to 2023. Oops. And I've done my data analysis. So for this part, I examined how indaziflam affected brome biomass and density using analysis of variance, and then log response ratios, which is just the natural log of the treatment biomass, for example, divided by the untreated control plot biomass. So here's a log response ratio graph that I use, and I'll explain this. So on the y-axis, we have the 2 sites, so the Aden site and then the Pinhorn site. And then the different seasons of application, we have either fall or spring applied indaziflam, and then the different rates going from lowest to highest. And so this is showing the log response ratio. If the log response ratio is 0, that means there was no treatment effect. If it's negative, that means that the brome is being reduced because of the indaziflam treatment, and if it's positive, that means it's like increasing because of the treatment. So this is showing the mean in the 95% confidence interval. So in the first like immediate growing season after our indaziflam treatment, we did not see any changes in brome biomass due to any of the indaziflam treatment. Then by 2021, we did start to see some treatment effect of reductions in brome biomass. And what we were seeing was that also the fall applied treatments were having greater reductions than the spring applied treatments. And then by 2022, we saw quite large levels of reductions. So in 2022, all treatments were reducing biomass by at least 80%. Compared to the untreated control, that is, and except for maybe like some of the lowest rate treatments, like that 37.5 gram treatment, that was still reducing biomass, just not by as much. And finally, in the last year that we sampled, which was 2023, we continued to see reductions in biomass in most of the treatments, except for some of the lowest rate ones again. We saw potentially a slight improvement with the double rate as time was going on. That one was still like lasting in the soil. But looking at the recommended rate, so the fall 75 gram rate, we were seeing 11 to 99% reductions at the Aden site and 66 to 100% reductions at the Pinhorn site. In terms of plant density, so how many plants there were in the plot, it was a fairly similar story in that no effects in the first year, fall better than the spring in the second year, larger reductions on the third year, and then continued reductions in density in the fourth year. So 2023, we were seeing 95 to 100% reductions at the Aden site and 76 to 100% at the Pinhorn site. And one thing, so yeah, that was promising. That was good. The indaziflam seemed to be working to reduce the brome. But one other thing that I found actually super interesting at our sites was just looking at the annual brome dynamics, sort of apart from the indaziflam, because this was something that we noticed. So at our sites, we actually saw really marked fluctuations in brome between years within the non-treated field plots. So just plots that were not treated by indaziflam, or if you are just like looking at the site without indaziflam treatment, what we saw was that in the first 2 years, there was like really high levels of invasion or high levels of brome biomass there at both of the sites. But then in 2022 and 2023, you can see that really dropped off. And that was just a natural drop off. And so we kind of think it could be related to precipitation. So those are the precipitation levels that we had in each year. But what we noticed is that we had really low fall precipitation during 2021. And so that could have led to less brome germinating in the fall and therefore like less growing in 2022. But it also sort of brings the question, like, could our northern temperate mixed prairie plant communities be more resilient to annual brome invasion? So that is definitely something that I think would be really interesting to understand more. So that was the sort of the brome response. Then the second part of my research was about determining how the indaziflam treatment affects the rest of the northern mixed prairie plant species abundance, composition, richness, and diversity. So yeah, the rest of the plant community is also important when you're looking at restoration and how it's responding. So this was accomplished by doing a field study, seed bank study, and a root biomass greenhouse study. So I evaluated indaziflam effects on perennial grass biomass and total biomass using those log response ratios again. I evaluated diversity using analysis of variance. So I looked at Shannon's diversity, Simpson's diversity, species richness. I looked at the plant species composition using Permanova and non-metric multidimensional scaling. And I also looked at the cover of the 3 most abundant perennial grasses. I looked at forb and perennial grass seedling emergence and root and shoot biomass of greenhouse grown perennial grasses using analysis of variance. So here's the perennial grass biomass results. It's that same log response ratio graph. So what we saw was that perennial grass biomass throughout those 4 years remained stable or even increased under some higher rate treatments. So you can see like under some of the 150 gram treatments, increases in biomass. But so that's good news that the perennial grass biomass was not decreasing. It was remaining stable or possibly increasing, probably as the brome was being controlled, there was less competition, and it could increase in its biomass and cover. This is total above ground biomass, so like total forage biomass. If you're looking at how much forage there is going to be for animals. So total above ground biomass initially actually decreased as the brome was being reduced. So it was decreasing in 2021. Then it started to increase again as perennials replaced the brome. So by 2023, it was like stable or a little slightly higher than the untreated control plots. So that was also positive. For plant diversity, for the first 3 years of our study, from 2020 to 2022, there were no changes in plant diversity. But then in the 4th year of 2023, we did observe some changes due to indaziflam treatment. So here it's showing the 2 different sites, and then the non-treated is in the like white color, and then the indaziflam treatments are in the other colors. So what we saw was that diversity and richness were slightly lower within indaziflam treated plots, and that these reductions were occurring even with low rates of indaziflam, so even with the half rate, the 37.5 gram rate. So that was a little bit interesting, and I wanted to look further into what was kind of driving that change in, or what species were driving those changes in diversity. So here is an MDS, that's non-metric multidimensional scaling graph. So each of the dots here on this graph is a plot and its species composition that we measured. And so the different colors are the different treatments. And if the dots are closer together, that means they have a more similar composition to each other. So the non-treated plots are in green, and then the other colors are the different indaziflam treatments. So what we saw was that indaziflam treatment, so like these arrows, were associated with a shift towards Pascopyrum smithiae, that's western wheatgrass, and perennial grasses in general. We saw a shift away from like blue grama grass, that's Bouteloua gracilis, and some forbs as well. And that was further seen within some other analysis that I did of the cover. So just looking at the western wheatgrass response of its cover, we saw that, yeah, this western wheatgrass, which is an important forage grass, its cover was increasing with indaziflam treatment, particularly at one of our sites. And then like Bouteloua gracilis, blue grama grass, and another important forage grass, needle and thread grass, that's Hesperocypa comata. Those are declining in cover. And so the western wheatgrass is more of a deeper rooted rhizomatous grass. So I think that could take advantage of new niche space being available. It can rapidly sort of move around with its rhizomes compared to a bunch grass like needle and thread, but then also having deeper roots probably maybe makes it more tolerant to indaziflam if the indaziflam is kind of staying in the top layer of soil. So to further look at how things might be changing, I did a seed bank study. So in June 2021, we collected soil cores 0 to 5 centimeters deep from the fall treated indaziflam plots at all rates, and then monitored the emergence of seedlings in the greenhouse for 8 months. So what I found was that indaziflam negatively affected native forb seedling emergence more than native perennial grass emergence. So here is the emergence at both of those sites. The forbs are in yellow and pink colors, and then grasses are in green. So you can see as the rate of indaziflam was increasing, there was a pretty big drop off in forb emergence. But also in this seed bank study, we also just found that the overall emergence of seedlings, even in the control plots, is quite low. There's 6 or 8 seedlings emerging here per volume of soil that we had, which was pretty low compared to how many annual brome seedlings were emerging. So in these same untreated controls, there were hundreds of brome seedlings emerging. And finally, I did another greenhouse experiment looking at how indaziflam was affecting already growing perennial grasses, because there was not a lot of information about that. It was mostly about how it's affecting the seedlings. So I wanted to see, can it affect already growing grasses? So I planted 4 of our most common perennial native species, which are western wheatgrass, needle and thread, blue grama, and Sandberg's bluegrass. Those were grown in the greenhouse for 2 months. And then at 2 months, we treated them with indaziflam at 0, 75, and 150 grams and let them grow for 2 more months. Then when they were 4 months old, I measured the root and shoot biomass. So what we found was that the root and above ground biomass of those 4-month-old perennial grasses that were grown in the greenhouse declined with increasing indaziflam rate. So the indaziflam can affect those already growing plants. It also affected the root biomass of the shallow, middle, and deep root layers. So I guess we expected maybe that the deep layer would not be as affected, but it could have been because since it's a greenhouse experiment, indaziflam is leaching deeper into the soil. But typically in the field, we would expect indaziflam to stay in the top soil and leave the deep roots less affected. So this was interesting and kind of different than what we saw in the field. However, in the field, we had those competition effects, so that kind of plays a role in how the perennials are doing as well. So they might be slightly negatively affected in the field, but because they're also having less competition for resources from the brome that's being reduced, they can still maintain their biomass and maybe even increase it. So yeah. Overall, from all that information that I learned, here are some of my management recommendations. So I think that because there was no impact to forage biomass in the field, meaning that there's pretty minimal concern for grazing, and given that the diversity of native plant communities in the US has been compromised by annual brome invasion, I think that a one-time application of indaziflam to attempt to contain or eliminate the brome seed bank could be beneficial despite small and likely short-term reductions in diversity. But I do think that sequential applications could start to compromise diversity by preventing forbs and grasses from regenerating from seed. I also think that applying indaziflam onto smaller patches of an annual brome could proactively help contain the spread of this across the province, especially because we don't have super large areas of it yet. So I think waiting to manage at a later stage would require more herbicide, possibly greater expense, and potentially a risk of longer term loss of diversity. And I also think that ecological and economical costs would be larger across a larger scale application area. Yeah, those are just my thoughts, I guess. But here's some more practical recommendations. So to maximize the efficiency of a single application of indaziflam, the application should preferably be done in the fall prior to dormant season moisture, so that maximized early season control that we saw. But if that's not possible, then waiting until the spring still results in measurable reductions in the long term. The recommended rate of 75 grams of active ingredient per hectare was appropriate for our high organic matter soils. The lower rate was not as effective in the long term, so there's probably no benefit to using that lower rate or to lowering the rate, especially because it didn't really have any measurable benefits in terms of diversity or anything either. And then the double rate also, I don't think provided enough benefit to justify doubling the rate of herbicide. I also think that it's unclear how widespread and severe these annual brome invasions will become in the grasslands of Western Canada. I think there can be panic about these species, seeing what they've done in the United States, and I think that that's fair, but I also think we don't know enough about it, how they act in our more northern grasslands. Because I thought it was really interesting how we saw a reduction in annual brome within our non-treated plots and how that occurred without the assistance of herbicide treatment. So I do think if annual brome invasion within Canadian prairies is not as aggressive as in the United States, there may be less reason to implement widespread use of indaziflam. And yeah, thank you. Funding was provided by Alberta Environmental Parks, MVU, and the Rangeland Research Institute, and we had a number of collaborators from the Range Management Branch. The Pinhorn Grazing Reserve and Ross Ranch were our really awesome study sites, and yeah, thanks to everyone who helped out on the project, and thanks to everyone who is here listening today. So hopefully there will be some questions.
First of all, thanks so much. A lot of hard work you've put in there. Wow, it's unbelievable. We already have quite a few questions that have come in. So I'll just kind of give them to you rapid fire, and if you can answer them, great. If not, that's okay. The first one is from Colin. How long are brome seeds viable in the land? Can they persist over several dry years and then sprout?
Yeah, so what I saw from what I've read is that they're typically viable in the soil for 3 to 5 years. Yeah, I think that's if they're dry as well. I've also seen that they can if they're dry, they can remain viable for up to 10 years maybe. But typically, if they have the conditions to germinate, they're going to germinate in the next year. If they have the right conditions to germinate. But typically 3 to 5 years. That's what I read. So you would want to try to, I guess the idea with indaziflam is that maybe it could last long enough to actually deplete the brome seed bank.
Okay. While we're on the seed topic, we got a few more. Do some bird species eat the seeds? Can bird populations make a difference?
Yeah, that's actually interesting. I think they can, but what I actually read, because I was reading about how these species were affecting like wildlife and native mammals and native birds, but it seemed like in this one study that I read, native birds actually they prefer native seeds of native plants, so they kind of avoided these seeds, and that was like leading to a reduction in their food source, but that I don't actually know too much about whether like how much they would eat these.
Yeah, how much of an impact it would make. Maybe for your PhD.
Yeah.
And then would controlled burns work to burn the seed?
I think I think what has been found is like with this fire return interval thing is that these species are pretty like bad after a fire. It's sort of like a positive feedback loop where they're flammable and then they result in a fire. Then they're like the first species up after a fire, and they can outcompete the natives after a fire. So I don't know if a fire is like hot enough to kill the seeds, but I have seen some studies where they use burning in combination with like herbicide or in combination with something else like revegetation. So I think it would maybe in combination with something else.
Yeah. That's interesting that they're like you called it the positive feedback loop, right? They're flammable, so then they can get first dibs at growing. Interesting. That's why they're invasive, right? Would mechanical mowing cycles work against brome grass?
I yeah, the one study that I've kind of read, which is like a meta-analysis about control methods for these, and that's what I was referencing in like when I was talking about grazing and stuff. I don't think mowing like really seemed to be a great option in that meta-analysis. And also like these species they're making so many seeds and putting them into the soil. I think it would be really hard to get rid of it in that way.
Okay. And Jessica's wondering, have there been studies looking at herbicide control during non-drought conditions? Could the drought conditions be another variable into the control change in vegetation, especially since blue grama did great while the cool season grasses did not?
Yeah, I think that would be ideal for sure. I think when we're comparing our treatments to the untreated control, like that's why we have an untreated control, is because that does like help us, or it provides that like buffer for differences in precipitation throughout the years, because we're always comparing it to untreated control that's also going through the drought conditions. And I think right now like there's never going to be a time to like do a study where the conditions are perfect, and it seems like drought is becoming common now, or like weird weather conditions are becoming common. So we have that untreated control to compare it against. But yeah, it would be good.
Yeah, for sure. Thanks for that answer. And another listener is wondering if you considered smooth brome in your studies at all.
So smooth brome is a perennial, and so we were mostly looking at annual grasses. And also in our grasslands in Southern Alberta, we don't have too much smooth brome, except maybe on the roadsides. But I think smooth brome is more of an issue in like more northern, like parkland. But I don't think indaziflam would be a great candidate for smooth brome because it is
Okay.
a perennial and not an annual.
Okay. Okay. And then being a non-native grass, would it eventually become a native grass or part of the habitat in grasslands as is a major grass found across the prairies?
The annual brome?
The smooth brome. Yeah,
Oh, the smooth brome?
smooth brome.
Sorry, what was that question?
Would smooth brome, because it's a non-native grass, would it eventually become native or become part of the habitat in grasslands because it's so common? Like, I guess would it be classified as
right.
naturalized then?
Right. Yeah, I think smooth brome. I've seen it in the grasslands on the roadsides. And like ditches. I think it likes a little bit more moisture maybe than in the grasslands. So yeah, and
Yeah.
I think it is considered naturalized in a lot of the parkland at this point.
I live down near Grasslands National Park, and it tends to grow near the rivers. And I think it's at a point too where it's kind of naturalized. It's been there for so long and so well established. There's not much that can be done for it, unfortunately. Yeah. There's a comment from Kelsey. There is some research out of Fort Ko, pardon my pronunciation, in Miles City, Montana, that the fire interaction with these bromes is different in the northern grasslands, and fire is likely more beneficial here than in the sagebrush steppe. Do you have any thoughts or comments to that?
Oh wow, that's like really interesting. Yeah, I'm gonna look into that because I think that's really interesting that there's like other studies about the differences between northern and southern
Mhm.
control because I do think that there's like quite big differences and we can't just take everything that they do in those sagebrush ecosystems and apply it to more northern climates. So yeah,
Yeah.
yeah,
Yeah, it'd be
thanks. I'm
interesting.
definitely gonna
Yeah.
check that out.
Mm,
And yeah.
And that's Kelsey. And Kelsey, from my memory, is based in Montana. We've been in touch for a while, but involved with quite a few different things going on there. So, yeah, I can connect you guys afterwards if there's a conversation to have if you'd like. Yeah. And then Cliff says some ungrazed areas in Alberta seem to be much thicker with downy brome. Is grazing in conjunction with indaziflam a must for best control?
Yeah, I definitely think that it would be great to combine those two things. Um,
Mhm.
and I think grazing can definitely play a part in this control. Um, there's not there's not a restriction period after applying indaziflam for grazing.
Oh, okay.
So yeah, I think especially in the early spring, that's when it's the most palatable, and that's before the seed heads come out. So I think that's the best time to try and graze it
Okay.
as
Okay.
well.
And earlier in your presentation, you were talking about how products are registered essentially. Could you tell us a little bit more about that process, or if you know?
I mean, I don't know too much, but I know that they do trials and they compile data from different research projects. I think my project data is also um, contributing to that as well. And then I don't know.
Decide if it's worth registering and making
Yeah.
available for consumers, I guess. Yeah. Okay, that's interesting. And I noticed some of your data took place in like kind of 2020 to 2023. Did COVID have an impact on your research at all?
Um, well, it definitely took some like persuading to allow us to go out into the field, but um No, we were still able to do everything that we wanted to do, which
Oh,
was
that's
really good.
great. That's great. Yeah, there's so many research projects that were like either came to a complete halt or paused or yeah, so that's awesome that you were able to still get out and it didn't have an impact. And one of our listeners is wondering if you have a rough idea for the cost of indaziflam, let's say 75 GM per hectare treatment, and once it becomes available, if you could ballpark chemical or labor if you would know it, and yeah, just the cost of that
Right.
treatment.
Yeah, I don't know too much about how much it will cost here. I think it is fairly expensive. I don't think they decided on a cost yet. And I think in the US it's I could check what it is in the US. I forget now. I'm sorry.
No problem. And one of our listeners is wondering if herbicide treatment is not an option, can we eradicate by removing prior to seed emergence and introducing other native palatable seeds? Do you know anything about that?
Sorry, could you say that again?
If herbicide treatment's not an option, can we eradicate by removing prior to seed emergence and introducing other native
Mm.
palatable seeds?
Yeah, I think revegetation is a strategy. I think it's probably always good to have more native species growing there,
Mhm.
which would not allow for it to like become as established. I know in the United States where they have pretty degraded rangeland, it's like overgrazed
Mhm.
and like very dry, or in the sagebrush systems where there's like big kind of open gaps, that's where it can more easily invade and become very well established. So yeah, I think maintaining a robust plant community is key.
Awesome. That's good to know. That's all the questions we have right now. If any listeners out there have any burning questions, feel free to type it in. We'll give you another minute or so. And I just want to mention to everyone that we've been recording today's webinar, and it will be up on PCAP's YouTube channel in the very near future. That's youtube.com/user/skpcap. If you haven't checked out our YouTube channel in the past, it's awesome. We've got like 200 different webinars on there on a variety of topics. So if you want to learn to identify invasive species or if you're looking for something species specific, feel free to check that out. Yeah, and when you leave today's webinar, we, as always, have a quick 1-minute survey. If you don't mind filling that out, we really appreciate that so we can report back to our funders and partners in the future about how our speaker series is going so we can keep it going into the future. And Anabel, I don't see any more questions coming in. So I just want to say thank you so much for taking the time to share your research. It was really detailed and thorough, and we really appreciate it. And thank you.
Yeah, thanks everyone for all your questions, and thanks for coming to listen. I'm glad that we could talk a little bit about annual brome invasion.
Absolutely. Absolutely. Well, thank you and have a great rest of your day, everyone. Bye now.